Agents. Let's talk about agents. Agent is very overloaded word due to AI, currently, craze and stuff like that. So I'm going to talk about what is agent for us. Agent for us is just some piece of code, mostly agnostic of the current execution environment where it runs, which accepts some inputs and based on that produces some outputs. That's it. Where we came with the idea of agent and why we are talking about the agent. Well, you know, I am a little bit hardcore gamer. I like to play games. Massive multiplayer online games, all sorts of games. In a genre of immersive simulation and hardcore survival. But immersive simulation, this is a key thing here. So I was working before, was building smart contracts and all kind of Web3 solutions for Somnium Metaverse VR that required a lot of kind of simulations for the virtual reality world. I played such games as Elite Dangerous, I played such games as Minecraft, let's say, and many others, like Rust. What I have noticed, the problem is that all these systems, all these games, all these immersive simulation platforms, they're client-server based, where you usually have some cloud, doing some computations there, simulation of the whole game, and that can accommodate at any time point just a certain amount of users. Because clearly, if you run one continuous virtual world in one or a few servers, you're facing lots of technical problems. You have to figure out what you're doing. You either have to make a compromise for accommodating more players at the same time, and then you have to make a compromise in terms of game mechanics and experience, or you want to deliver much richer experience but on expense of cutting down some number of players, because it's too much to simulate, too much to compute, too much to coordinate of states between all the players in different parts of the world. So I thought, okay, this is very complex. Why not we do something else? For instance, if I live in my part of simulated world and some players in their own parts, why should we all talk to the same server or the same even cluster of servers in the cloud? Why not me simulating just my piece of world somewhere here locally and some other guy in his part locally on his computer? And when we meet each other, right? When we meet each other, then we start proving to each other that we didn't cheat, and our character simulations or whatever were happening according to the game rules. Okay, this is quite interesting idea. It's crazy idea a little bit. It's not easy to solve, I admit. But as the first stepping stones here would be how do you actually represent different parts of your local simulation, how you generate proofs, how you package all this, in what data structures you're going to use to generate proofs and to deliver these proofs to each other. And the answer is simple. So simply tokenize. Like tokenize different NPCs, tokenize your character, tokenize your variables, tokenize items, and so on. So for every object in this world, in the game world, we create basically a token and supply this token with executable code that can calculate current state, and based on that, create a next state, and then use also so-called verify function that checks the transition from state A to state B was correct, plus generate proof that you didn't create two versions of any of your simulated part of the world. So it means that you prove always that your game simulation was unique. At any given time point, you don't have any alternative simulation, and your game simulation happened according to some specific game rules. And when I meet my counterparty, and we decide to make a battle royale or whatever, I prove to him that I have this kind of weapons, this kind of armor, this kind of armor, all kind of stuff, all my stats are like that, and he proves to me the same. And we can play with each other, do some battle or something, some interaction, and then generating proof of correct interaction. So for further, if we meet other members or other players, we also proving to them that everything was done, and they can verify that our game simulation was correct. What this brings to us? This brings us to very simple definition of agent. What is agent? Agent that can be used not only in games, it can be used actually anywhere, in any kind of application field. So agent for us is just a program, okay? This box is executable code, yeah? Executable code. It has its state. It has function, execute. Receiving current state as input, current state, some external inputs, and producing some new state. Okay? And then it has function verify. Where it takes current state, input, and new state, and returns true or false. That's all. So this kind of model, we use Unicity tokens. You remember that in Unicity token state we had this data field. In data field of the token, sorry. So this is our token. This is our data field. In this data field, we record the current state of our agent. And when we want to execute a transaction, yeah, we have also some unlocking condition here. We provide inputs to unlock. Let's say it's some private key. Okay. Oh, sorry, public key. We provide a signature. And we provide some input for our agent to execute. And then agent runs and calculates a new state for our token. It could be, by the way, same owner, or it could be some other owner. And we get a new state here. That's all. That's it. I'm just trying to be very abstract here. So the rest, how agent is operated, what it does, how the verification works. Is it just a simple recompute or some zero knowledge, or it's just attestation by some trusted parties? It's not all. It's not. We're not specific here. So it's fully business case specific or application specific. So based on that, you can basically build any kind of application that generate verifiable trace of its computation. And in this idea can be used basically to build applications, online applications, that don't necessarily require client-server kind of architecture, so you don't necessarily need to run it on the servers. You can run different parts of this application on clients.
So question, is the agent the same as a token which implements a state machine?
Agent is actually a specific execution, let's say, component that defines how token evolves.
Okay, so basically it's a token or more tokens, and we're runtime on execution environment.
Yeah, I would say so, yes. So it could. I was thinking in terms of single token. So basically, token and agent could be, you put some kind of sign of equivalence, but basically, the token is mostly, it's a way to trace execution, to trace and verify, so to record execution, verify execution of an agent. And agent is just a piece of code that provides us execution and verification components. But those agent and token, though, basically they make up together a single part, single piece.
Thank you.
All right, that's it. Thank you very much for your attention. If you are interested, please follow us.